As we know, the role of cloud engineer is overarching and the boundaries are fuzzy. Depending upon the organization, it could be just building cloud infrastructure, but the truth of the matter is that these days, a cloud engineer is supposed to do or at least facilitate support to everything which touches the cloud. The application software which runs in cloud doesn't exist in vacuum. It not only contains code but also makes sure to make use of various cloud services. A typical cloud application lives in a virtual network, makes use of egress and ingress rules, obeys the identity access management, and follows defined security patterns. That is the key concept here. No matter if the application resides on a virtual machine or is it serverless or it's container based, it has to remain in the ambit of security guardrails defined by your security team. It's a job of cloud engineer to make sure that application developers have a very crystal clear idea about it while they build their application. From CI/CD pipeline to production access for users, developers should know what's the defined secure path here. For example, if application needs to talk to some public endpoints, don't just let developers put the application in public subnets or let them create their own internet gateways. Give them a proper, defined, secure way to do so. That is the actual job of cloud engineer when it comes to providing support to the application security. Now, during your job as cloud engineer, you'll be working hand in hand with your cybersecurity team and various other stakeholders, including the developers, to make sure that application security is hardened. Following is a list of concepts and key things which cloud engineer must know to talk intelligently to the stakeholders like cybersecurity engineers, developers, product owners, and architects in your organization. The first concept is identity access management. This involves that cloud engineer must know that what sort of authentication and authorization and such as IAM keys are required by the applications and how developers can utilize these concepts in their application. You need to provide them an interface. Then comes the review of application architecture from the cloud um, tenancy perspective. You as a cloud engineer must know that how the application is architected, what cloud services this application is touching or need, and what are the cloud integration outside of the core services, and is there any clear demarcation between the application and the services it is accessing. They shouldn't be tightly coupled but rather loosely coupled. Then comes the storage part for the application. If this application requires any data store, then as a cloud engineer you should be asking the questions like how the data is being stored. Is it being stored in a cloud managed service like RDS in AWS or any NoSQL database, or is it a key value store, or if the data is being sent to some sort of searching data store like Elasticsearch or OpenSearch in AWS. And then as a cloud engineer, you need to make sure that whatever technology is being used for the data store, there is an encryption at rest and encryption in the flight. Another key concept for cloud engineer here is that he or she should make sure that database or the data store should be in a restricted zone, where your application should be in a private zone. The conceptual difference between private zone and restricted zone is that the private zone is normally accessible through the intranet, where restricted zone is only accessible through the private zone. So the application works like this. The end users are sort of in the public zone. They access the application server which hosts the application in the private zone, and then this application accesses the data store in the restricted zone, and users or even developers should should not be accessing anything in the restricted zone directly. Sorry. And then cloud engineer must make sure that there are SSL certificates and there is a clear life cycle for them, how they are being obtained and how they are being renewed. And SSL should be enabled for the application. There are some application requirements where SSL certificates are obtained from outside CA. When I say outside CA, it means that other than the cloud. And in some cases, the CA is provided by the cloud provider itself. The benefit of a cloud provider CA is that normally the cost is very low, and more importantly, the certificates are auto renewed. Then we have the concept of application type. Cloud engineer must know that what sort of application is this? Is it a SaaS service which is hosted outside of your cloud? If that is the case, how that is being deployed into the cloud? What are the integrations? What changes would need to be made in the cloud? And then you should also make sure that this SaaS service is hosted outside of your cloud and then outside of your cloud. Now, having said that, um, if this application is in-house, then as a cloud engineer, you must make sure that this cloud is hosted properly on any of your infrastructure as code service in the cloud, like if it is EC2, if the security groups are configured, if the NACLs are configured, routing is there, what is the egress, ingress, and various other things. So application type defines how you would be implementing the security within the cloud. Every application, whether it's an internal one or an even SaaS one, they make use of the standard libraries. As a cloud engineer, you should be working hand in hand with your cybersecurity team to make sure that there is a software composition analysis tooling, which is part of either your continuous integration pipeline or your Git repository, and it should be scanning those standard libraries to make sure that there is no vulnerability involved. Secret management is a huge and very important part of any application. If the application is utilizing any standard username passwords, or it is working on keys, or if it is the authentication um, is working through some SSO. So as a cloud engineer, you must be facilitating that usage. And the less username password are used and managed, the less overhead there is. But if that is the case, you should be utilizing some secret management software such as HashiCorp's Vault or even AWS Secrets Manager, and there are plethora of others. As we already mentioned that this should be crystal clear where the application is being hosted. Is it in the public zone or the private zone? Normally, it is preferable to host it in the private zone and behind any firewalls and all the security guardrails so that there is no internet exposure. And when that's done, you should be providing some egress and ingress towards the internet. Application networking, again, that directly deals with how if the application is being hosted in the private zone, how the ingress and egress is working. If the application is taking sensitive data from the customers or even from the end users, and especially if it's an unauthenticated input, then developers should be doing all the validations in the code, and you should make sure through some sort of tooling that developers are doing so. We should have also some application firewall to make sure that if the validations are weak, we are doing some sort of validations and checking at the firewall level, such as SQL injections and cross-site scripting, and there are a host of others. Logging and tracing is another very important part when it comes to debugging and auditing. So instrumentation is the key. Developers must include some sort of instrumentation into their code so that application is traceable and easily can be audited by any third party or for the cyber team or security team and the cloud team. The logs should be generated and sent to some centralized location for any vulnerability detection. And there are various tools available for that. Application monitoring is a key, and application APM tool or application monitoring, performance monitoring tool should be utilized, and there are like hundreds of tools available out there like New Relic, Datadog, and various others which should be utilized. And accordingly, they should be also doing some sort of initial testing on the code when those APIs are being called. I hope that this helps, and this again sends this message across that cloud engineer role is an overarching role. It encompasses everything under the sun if it is touching the cloud. So as a cloud engineer, even if you're not a cybersecurity engineer, you must know these concepts and should be ready to help out your organization when it comes to establishing a cloud security posture for the application related spectrum. I hope this helps. If you have any questions or any feedback, please feel free to put them in the comments. Thank you.